DMX 512 is still the most used protocol in industrial lighting. So how does it look like? We will have a deep dive now. Welcome to La Cave Inside. I'm Marcus, and today we are not in the studio, we are still here in the lab because I want to show you how the DMX protocol really works. Well, first of all, let's connect the lighting console to an oscilloscope that we can see what the signal is all about. So for this, I'm using here a standard optocoupler. Please make sure, if you want to do it yourself, that you're using a high-speed optocoupler, because I know there are a lot of protocols out there, they are much faster, but for UART, this is still a high-speed protocol. So, let's show the oscilloscope, and if we are going to connect it, then we can see here's some signal is coming. Now I have hooked up the ground, and we have now here a fully working DMX signal. What you can see here is always a full frame. So let's stop it for a second. And now from here to here, this is a full DMX frame with all the 512 channels. Now we can see more. Let's patch some fixtures first. So for this, I'm going to the GrandMA and just patching some dimmers. For example, I think, yeah, 5 would be fine, so quantity of 5, please. We're starting at fixture ID 1. That's fine, okay, and good. Then I'm going to save some groups. So group number 1, group number 2, 3, 4, and 5. Next thing I want to do is hook up these ones to the sequences. So bring up channel 1 to 512. And for example, channel 2 for just 2. And channel 3 just to 1. It's all here in decimal, so that we can see better what's going on. Now, we first need to make sure that our oscilloscope is triggering on the right points. So in general, if we have a look at the DMX specifications, we can see that the reset signal needs to take at least 88 microseconds. Okay, so let's go to the oscilloscope and say stop and just zoom in a little bit. And if we zoom in more, then we can see in this frame over here that this is the reset one. So let's activate the cursor and then measure this one first. We know how long the reset signal of the GrandMA is. In this case, we have here almost 180 microseconds. So that means that we are inside the specification. The specification says 88 microseconds and we have 180, so that's quite fine. Okay, now we first make sure that we set the trigger point correctly for the oscilloscope. So in the specifications it says 88 microseconds, and we have measured here 180 microseconds, so that's fine. I'm going to choose, 100, 120, because the GrandMA is still sending a longer interval than we need to define and identify starting point. So let's set the trigger one to interval with 120 microseconds, not milliseconds, it's microseconds. Make sure that. And now, if we zoom in, we can see a correct starting point. So what we can see here is, this is the break, and after the break, there is the mark or the reset or the start byte. So you can see the mark and reset. This one is this here. And then it comes to start byte. So this is the start byte. And now if I'm going to control the faders, you can see here something is moving. So that means this is our first DMX frame. Let's zoom a little bit more in. Something like this. Okay, and now we can see this here are the 8 bits of our first channel. So if I pull the fader to 1, that's a little bit difficult. Let's do it via the command line. Put it to 1, and now you can see this jumping bit over here is the first bit. If I pull it to 2, this is the second one. If I put in 3, we have now 1 and 2 activated. So this is the main and basic thing how DMX works. So you have the reset byte, then you have the starting byte, and then all the 512 channels individually. So if I'm going to zoom out a little bit, you can see all the stop bits of the other channels. So channel 2 is, for example, starting from this point here. Channel 3 is starting from that point over here. Channel 4, we haven't set it up, channel 4. So let's select channel 4, and here, sorry, this is channel 4 over there. So now channel 4, for example, is on 255. And now it's down to 0 again. Let's have a closer look to this one here. And for that, I'm going to use a logic analyzer. So I just need to set it up first. Okay, now I'm going to load the logic analyzer, and we will grab some signal. For this, for example, I'm putting channel 1 on decimal 1. I'm putting channel 2 on decimal 2 and channel 3 on decimal 5. All right, so let's grab some data. Good, this is still enough. And with that logic analyzer, I have the functionality to say DMX 512, and then we see actually what's going on. So let's have a look over here. The first one is from here to here. These are still 180 microseconds. This is our break. So now the DMX receiver is expecting a mark. So the second one over here, let me do it like this. Second one over here is the mark. Now the receiver knows, okay, here should now come some DMX protocol, and then it's waiting for the first start byte. So this is the start byte over here. And now the next thing we got are here our channels. So for example, the first channel is starting from here to here. This is our first channel, and it says it is only 1 positive, and then the other 7 are negative. Up to here, the latest 2 ones are here the stop bits, but we just have a look at these ones. So if it means 1 is up, so in binary 1 is up and all the others is down, so it's still 1. And here we have the value of 1. Let's have another try on channel 2. So on channel 2, we have here our start bit of the next channel. Then we have number 1. Number 1 is still down, but the second bit is still up. So it means 2. And all the other 6 bits are still off. So it means a value of 2. And of course, I forgot the stop bits. Now let's have a look at channel 3. Channel 3, we have here the starting bit. Then bit 1 is set up to 1. 2 is down, and 3 is up again. So it is counting 1, 2, and 4. So now we need to add 4 plus 1, it's 5, so the value is 5. And we have here the stop bits again. And now we'll have a look at the channel 4. This is still down, so that means our start bit here. Then we have the information bits, the 8 ones, and these are still all down, so it means 0. That's why the value is 0. Now let's have another example on the oscilloscope. So I put everything down, but I'm using channel 1 in this case, and on the rotary I turn it up, and you can see, let's zoom in a little bit more, So the full channel is right here. Let me set up the cursor that we can see it better. So cursor 1 is starting from this. You can see the data. And the first one is the start bit of the channel. So if you only want to have a look at our values, so we need to focus from this point up to the stop bits. These are 2 in that case. So in this frame here, I can see the channels running. If I pull it up, now everything is on 255. And if I pull it down, you can see everything is to 0. So this is 1, the bit 1. This is the bit 2. This is the bit 4. This is 8. This is 16. This is 32. This is 64. And the last bit is 128. Alright guys, thanks for watching the video. I hope you liked it and enjoyed it, and it is helpful for you for a better understanding for DMX 512 protocol. So please don't forget to like the video and subscribe to the channel. See you next time. Bye bye.